This segment shows an animated model using Rhino and Grasshopper software to demonstrate the degree of freedom and versatility of the dynamic spaceframe geometry. The spaceframe geometry is made up of 14 conjoined dynamic space trusses. Its ability to fold, to expand and transform from a dish and then to a dome is both unique and highly innovational. It can expand to many times its folded size depending on the length of the struts. In this animated model, the expansion is 6 times greater. By adding actuated cables in the central actuator, the space truss can change shape from one form to another. Tension of the space truss is maintained by synchronized computer control of the actuators. This allows it to remain stable and load-bearing throughout transformations. The basic geometry of the dynamic truss is 2 opposed tripods whose feet are connected together, which allows the mechanism to expand and contract. This conceptual spaceframe prototype of 7 conjoined trusses is being manually deployed by the tightening of each of the central screws. Each of the trusses have 13 tension members and 6 common compression members, which form 2 opposed tripods. Each node has 6 pin-jointed connectors to accommodate a maximum of 6 struts. As the central post-tensioning actuator is shortened, the actuated cables are lengthened. When the central post-tensioning actuator is lengthened, the actuated cables are shortened. Asymmetrical forms can be realized by the addition of 3 lower surface chord actuators. This arrangement allows the deployed dynamic truss structure to be warped, wherein all the upper and lower chord members will have different lengths according to the amount of warp required. Alternatively, a means to reduce the number of actuators to achieve a simpler, more controllable framework is with a single actuated cable loop that runs on pulleys. This will allow the cable loop to independently adjust to the deformation of the truss while being formed into asymmetrical forms. It is possible to create nano, micro, macro, and megascale dynamic structural systems under this concept. It's a highly scalable, next-generation adaptive structure for architecture, aerospace, robotics, and many other disciplines.